This video is about Graphing Calculator Skill 3, Analyzing Polynomial Functions. This is example. So we put this polynomial function into Graphing Calculator. Let's go to way 1. We are looking for all zeros of this polynomial function and then find the solutions of f(x) greater than 0. Graphing Calculator, let's go to way 1. We are looking for all zeros of this polynomial function and then find the solutions of f(x) greater than 0. We press graph. This will be the graph of this polynomial function. We need to figure out all zeros of f(x). We got second trace 2. Go to very left because the window I set up from -5 to 5. So when we do this 0, I'm looking for very left zeros. So we do -5. Then this will be -1, -2. So I can do the -2. That's the right bound. So we got -4.59. Let's take picture about this. That's the first 0. Then go to the second 0. I do second trace 2. This will be -2. So I do the left bound, that's -2. Enter. Right bound, you could see 0 here. Enter. So we got this one is -0.82 is this one. So we still take picture. Now let's go to the third 0, second trace 2. Left bound, this will be 0. Enter. Right bound, you could see, let's move because it's hard to find the right bound. Yeah, I can move over here, put the enter, then enter. So we got 0.83. Yeah, take pictures about this. Now let's go to the last 0. So we do second trace 2. Move the arrow close. That's a left bound, enter. Left means on the left side of 0. So we're looking for right bound. Let's move over here. Then we put the enter. So we got another 0. So we got all 4 zeros. f(x) greater than 0 means domain of graph above x-axis. Now we want to figure out the solutions to f(x) greater than 0, which means we need to figure out the domain of all graphs above x-axis, which means these are highlighted graphs. For each 0, we already figured out by graphing calculator. Therefore, this will be the solution to this inequality. Now let's go to C, find f of 2. We press graph, this is the graph for this function. I will put the trace, then put the 2, enter. You will get the f of 2 equals 9. Second question for C, find all solutions for f of x equals 2. So we go to y, we put the y2 equals 2. Graph. Look at how many intersections you will get, 4. So you have 4 solutions. Therefore, I go to second trace 5. Enter, enter, enter. They give you this intersection. Let's take picture of that. Then you will go to the very right one this time. Second trace, 5. Just move the arrow close to this intersection. Then you will see enter, enter, enter. You got a second intersection. Then keep doing second trace, 5. Move the arrow to the third intersection, very close. Then you do enter, enter, enter. See, you got a third intersection. Now we do second trace, 5. This time you got to move over here. That's a long way to go. So let's move. It's kind of cross that. Yeah, so we go here. This is a very close also. You see enter, enter, enter. Then you will get a negative 4.61. So we still take picture. Therefore, you will get the 4 solutions. In other words, the solutions to f of x equals 2, you will get the following solutions: negative 4.61, negative 0.67, 1.73, and 0.56. D. Find the curve y equals f of x. Find the coordinates of all local minimum and maximum points. So look at this graph. I go to y equals, clear this y2. Then check the graph. Are they all minimum and maximum points shown on this screen? No, we couldn't see these minimum points. Therefore, we can figure out clearly this maximum and minimum points first. When we look for the other minimum points, we can change the window. So we do second trace, maximum, that's a 4. Left bound, you can move over here, yeah, enter. Then move to the right side of this maximum point, put the enter, enter. That's the maximum point. Go to this minimum, do the second trace. Minimum is 3. So move to the left side of this minimum point, enter. Then move to the right side of this minimum points, enter, enter. We got minimum points. Now, we couldn't see the other minimum points. We got to change the window. When we go to window, we just change minimum value for y minimum. We can do negative 50. Then for scale, we just do 5. Then check the graph. We still couldn't see this minimum. Therefore, keep changing the window for this minimum. We can do negative 100. Then for this part, I can do, this is a 10. And a graph. See, we could see this minimum this time. So we do second trace. Minimum is 3. Move the arrow to the left side of this minimum point. Then put enter. Then right bound, move the arrow to the right side of this minimum point, enter. So we figure out all maximum and minimum points for these polynomial functions.